request our respected HOD sir to introduce the chief guest on this session. Please, sir.
Good morning to everyone. I welcome you all for Institutions Innovations Council webinar on novel design ideas for innovative electronic products system competitions and expo organized by the Department of Electronics and Instrumentation Engineering of RMD Engineering College. The speaker of today's session is Mr. Ganesh Kanda, Senior Engineer, Microchip Technology Incorporations, Chennai. It is my privilege to introduce Mr. Ganesh Kanda. He did a Bachelor of Engineering, Electrical and Electronics Engineering from Dhyarajara College of Engineering, Madurai. He is an embedded system engineer and he can take care of the entire product life cycle, that is design, prototype, validate the design and take care of mass production of the evaluation kits and reference design for Atmel, AVR and SAM MCUs and wireless portfolios with includes Zigbee, Wi-Fi and BLE. He is also interested in developing firmware and some web designing and desktop applications. He is having very good skills in general purpose hardware design, layout engineering, RF hardware design, embedded firmware, production testing and certification. He is well familiar with tools for hardware design and simulation and software development. He is having good proficiency in computer languages such as C, C++, Python and Java and also bus communication protocols like I2C, SPI, UART, etc. He worked as a senior project engineer in Econ system for 1 year, 7 months and hardware engineer in Atmel Corporation for 5 years and 3 months. Currently, he is working as a senior engineer, grade 2, microchip technology, Chennai, since 2018. Really, we are very happy to have an expert for today's session. On behalf of our Electronics and Instrumentation Department and my own behalf, I welcome Mr. Ganesh Kanda and I also welcome our faculty members and students for this program. Now I invite the speaker to take over the session. Sir, please, sir.
Thank you, sir. Hi, everybody. Thanks for the introduction, sir. Hi, all. I see almost 60, 70 people in the session. We are going to have probably the next 1 hour discussing what we can do to win an electronic product show or an electronic design expo or a contest. With that background, like that's what we are going to do for the next 1 hour. I want to hear from at least, let's say, okay. First thing is this is going to be an interactive session. I don't have an class material. Like I'm not going to teach you a PID controller or an or how a Bluetooth works or anything like that. So it is going to be an discussion session. And if you are expecting that I would give you a list of 10 ideas which you go and present on any contest, you would win that contest. That's also not going to happen. So this is going to be a discussion session on what are the common things which we don't consider when we fail to make the cut on a contest, and how do we go about fixing that. That is the primary point of discussion for this next 1 hour or so. So I'm not going to give you ready-made solutions because I don't have. If you think that I have won every contest which I have presented so far, then probably I'm not the right person to do this session, because that's not the case with me. The last 4 or 5 contests which I applied for, I didn't get through. So with that background, you might be wondering why this guy is a speaker here, but that's how it is. So I'll but we will go through what all we have to do as part of the selection process, and we'll figure out what we can do better. So the first thing first is I want at least 1 or 2 of you to speak out on what do you think is the expected outcome from this next 1 hour. preferably a student. That will be like you can type it on the chat if you don't want to speak up.
Sir, hello, sir.
Hey, come on. Thanks, Devi.
Yes, sir.
Yeah, made my day. Yeah,
Sir,
tell
we
me.
expect to learn like in what areas can we implement electronics and where we can innovate and come up with new ideas, sir. And how can we proceed with it actually,
Okay.
practically speaking?
Thank you, Srividya. Thanks for the input. So yeah, that's precisely what I thought I will also do in this class. I didn't want to give you a list of 10 projects which you can do, but I thought I will present you some latest happenings on different technology. So then you can pick them up, join them together, and then you can think about what you can, how you can make it. How you can connect them together to make a product. Then you have a thermal screening drone, you have an COVID disinfection box, and then you see thousands of projects listed here with if you look at all these projects, there is, I will just highlight certain, I'll probably take a screenshot of it. Okay, and then you see this term IoT being used on quite a lot of places. Here. Okay, I can do this. I just did a search for IoT. You see like 31 hits on 1,000 projects. And then let's say we do a search for robo. You have considerable amount of robo here. And then let's do Zigbee. We have 4 or 5 projects with Zigbee. And then let's do Raspberry Pi. We have a couple of projects being written on Raspberry Pi. Then we do Wi-Fi. So if you jot down all the projects which you can do over a time, that will eventually boil down to one wireless technology trying to solve a traditional problem and expose it over something. So the let's say there is a Wi-Fi, there is a smart crop management for animals. So I mean protection system for animals. So you monitor something, you break it down, and then take it over Ethernet to some other Ethernet or wired connectivity to some other place. So eventually it boils down to this very basic sensor which senses an external input which is bothering us. We do a post processing. Some level of post processing here, and then we put it out over wireless in some technology like GSM or GPS or something. Okay, GPS you cannot do, but GSM, Bluetooth, Wi-Fi, something, and then it goes over the air to some other place where you look at the data. So you look at all the 100 projects around the world, or any project which you pick. If I'm not sure whether there are a lot of 4th years here, or you might be doing a lot of contests now. Any project which you are doing will eventually boil down to this setup. To drive a car, you write a code to drive a car that is still sensing the road, doing some post processing, controlling the wheels because of that. So that is okay. And then instead of putting it over there, I call it an actuation. So that is what that's what this entire thing is about. So so any project will fall into these 3 categories. So I mean any project will have these 3 components. So our goal will be to identify and segregate these set of components. So I mean, probably I'll draw it on a different color. So you, if you are like in a college preparing for contests and preparing for interviews, so you are okay, we'll take it a step further. So I'll do it part by part. So okay. So then you have this post processing interface, and then you have this is probably a control system or something like that, and then you have this output interface. So one way to look at all these contests and competitions is, why are you doing this? One thing is, there are probably a couple of reasons why we go to a contest. One is primarily because your college is pressuring you to do this. Second is probably because you want to get away from your daily routines. Third is probably because you want to learn. And the secret of making it to a lot of contest is to making systems which are reusable. So you split your ecosystem into three categories of algorithms and reusable components. So you make a sensor interface. You don't make that sensor interface for this particular project. You make it as a generic sensor interface. You make an actuator system. You don't make it for specific contest. You don't make it for a specific project. You make it as a generic system interface. By a generic system interface, what I mean is it should be pluggable. You write an algorithm for let's say detecting something. You write it in a way that it is reusable. So in that case, you develop what is called as a reusable components, which can be used over multiple projects. That's how every working company is making progress. If let's say if TCS can write a banking software in 5 months, it's not because they have people who are capable of writing that in 5 months. It is because they have built their repository over all these years, where they have written reusable components, so they can merge them together and make it into a product in a very quick span of time. If that's it, and plan for a slightly bigger span of time. So if you're preparing for a contest, you don't do it with a single contest in mind. You do like 4 contests. Okay, on the first contest, I will do 30% of this project and present it like this. On the next year, I will extend it to make it like this. See, one important thing is, I'm not quoting about any specific project. Okay, I don't want to block you within that idea of what I have. Okay, if I give you an example with this, then I'm sure the next 3 years you guys will be doing the same project. Okay, it has happened to me when I was in college. There is one guy who came and told, this is how you do project, gave you a set of examples on how to do it. Eventually the entire college did that same 10 projects because they couldn't think beyond that. We couldn't think beyond that. Probably I would have been also on the same age like you. So I'm saying that's why I am very specific, and I didn't write, instead of sensor, I didn't write water sensor here. Instead of okay, this is abuse, so I didn't defend that. Instead of actuator, I didn't write motor here. So this is an water level sensing project, okay? But I didn't write it this way, only on the hope that I don't want to block you within this minute set of ideas which I have. So I am just giving you design recipes, so you can take them, think of your project and do it that way. So you make, if you are making a second year project to something, you make a small part of the sensor, you do a minimum post processing in it, you do a simple actuation to it, and then show it as one part. And then over the time, you develop it. And at some point of time, you will have a better solution. So you will be working on your own without the expectation or the boundaries set by the contest as such. So you read about a contest from some company and then you start working for it. 90% of the time you will not make it to the cut, because it will be someone's wish list. It's not someone who made this project at that point. It is someone's wish list. So they were working on it for quite some time and they were not bounded by the timelines of this project. So you make preparing for the contest independent of the contest and make it as your goal. So let's say you make a 3-year plan. Tell that at the end of the 3 years, I want this to be done. And then I extend this and make it to my final year project. Okay. I've been speaking for so much time. I'm not even sure whether I'm online or not. Okay, I hope I am here. But okay, I'll stop here. And okay, I'm sure there are a lot of professors here as well in the class. But this will be a slightly not so safe question to ask to a list of students. Okay, but how many of you think that, you can put it on the chat, how many of you think that you will not buy your final year project outside? Okay, I'm sure in every college at least 30 to 40% of people buy their project out. Okay, can you commit that I will not buy my project out, I'll not do this project at a different place, right? So like how confident will you be to say that you will not be doing that? Someone can say, okay, I'll not do this now. I will, whatever happens, I'll do my project on my own. However bad that looks, I will still do that. Okay, that kind of a confidence. Okay, I've been helping a lot of students out. A lot of people, the worst part of that is I help people who buy project from outside and help them configure them to run it, which is the worst thing which I would ever want to do, but I still keep doing that.
Yes,
Yes,
sir.
sir,
Yes,
you're
sir.
audible, sir.
Okay, thanks, ma'am. Okay, so students, yeah, I think Shobhan is trying to say something. Come on, Shobhan.
Yes, yes, sir.
Yes, sir. Tell sir.
I
Tell sir.
I will do my project on my own. Whether, as you told, it might be as bad as possible, but yes, I'll try it to my best.
Okay, thanks. So that is that. Okay, if forget about all these contests and on this expos and everything. So your final year project is your contest. Okay, so at least if you can do that, that is some respect to your college and all the textbooks which you studied throughout the 4 years. So that is something which you should all do. Okay, so I'm just making a plan for that. Okay, so I started with this webinar on novel design, but now my plan is to tell you to make a project plan for the next 3 years. Okay, 3 years, every quarter I'll at least make some progress towards making this thing. Finally, probably your final project will be different from what you're trying to do. But if you make it to the cut on every quarter, like by the end of August, I'll at least try to write a code which can do this. By the end of December, I'll at least connect 2 transistors in a differential mode and try to find out how much is the amplifier gain of it. By the end of the next May, I will do this. I'll connect a sensor to the differential amplifier and see how much gain I can get out of that sensor's input. Something like that. So if you think of a big project, split it into small, very small chunks and do it every month, every 2 months. Have a smaller goal for that and do it every 2 months. And okay, we are all there. Every professor here, you can reach out to me, but every professor there will be able to help you. If you go and tell them that, sir, I'm starting second year, I'll be here for the next 2 years. You want it or not, I'll be here for the next 2 years. I'll only complete this degree and go. And in this 2 years, I want to be doing this project. And can you please help split me this into these smaller number of chunks? And I'll have a goal for every quarter. And if this works, then I will take this. I will take this approach. If it doesn't work, I'll take this approach. Add these 2 things together. First meeting, I will make a sensor which can talk to this interface. On the second quarter, once the microcontroller course is done, I will buy an Arduino, write a code to do a Bluetooth transfer. Third month, when the Arduino and the sensor is available, I will connect both of them together together and try to send it out. So if you make a project plan like this, then you will have lot of building up recipes which you can pick up and join them together and make it to a contest. Every company in the world works that way. So, and if it becomes collaborative, then you know your friend is doing a sensor interface with a Bluetooth. You know you are doing with a Wi-Fi. Then if there is a contest which requires you to do something with Bluetooth and Wi-Fi, then you can join with that friend and make a better project. As long as all of your code is reusable. Okay. Forget about reusability. நீங்க வந்து ஒரு 10 லைனுக்கு மேல கோட் அடிச்சிருந்தீங்கன்னா பெரிய ஓகே 10 ஃபைலுக்கு மேல கோட் அடிச்சிருந்தீங்கன்னா பெரிய விஷயம். Worst case நீங்க அதை புரிஞ்சு செஞ்சிருந்தீங்கன்னா then you can always take it out and integrate it with somebody else. So the basic so you have a basic repository of basic fundamental working blocks, and the blocks are which that is how this paint is designed. Okay, if you start paint from scratch, nothing will work. Paint gave you a list of repositories. It gave you a way to draw line, it gave you a way to draw square, it gave you a way to draw circle and all those things, and you pick and choose all these recipes and make this. If you go to a 5-star hotel, they make pre-made gravies for palak, they make pre-made gravies for Manchurian, they make pre-made gravies for vattakuழம்பு. You go and order vattakuழம்பு, they do a mix of it and get it out. If they have to make everything from scratch, we'll never make it to the cut. So how is your home built? With individual building blocks of bricks. As long as you keep working on these bricks and have individual working blocks of something, you can add them together and make it into a bigger final year project, bigger contest project, bigger everything project. Okay. Okay, that takes me to this. You have a product development role in which you put this. You have a set of constraints. Your board cannot be this big. You cannot consume more than this much amount of current. You want the product to look like this. You want the product not to radiate anything out, something like that. So you have these set of constraints, and then oh man, this block diagram is okay. And then there is an LDO. Okay, that's also another question. So someone, if you can unmute and expand what an LDO is, that'll be great. Okay, and then there is a battery charger. So yes, so it tells you the location. It has a display, so it can tell you what location you are in. It has a way to charge its battery, so it will be like a mobile phone where you can plug it into something and then charge the battery, and then the battery. It's a battery operated portable device which is connecting over UART. Can monitor your sensor temperature, can monitor the rate in which you are running. So it can be probably and what do you call it? Something like a Fitbit or something like that. So it has an accelerometer, so it can sense what speed you are running at, and then it will know your location as well, and then tell you how slow, quicker you are going, and then it can transmit all those data over Bluetooth or Wi-Fi to your phone, from where it can go over to the cloud. So this is this is how you read a block diagram and figure out how you understand the product. Okay, so coming back from that top level, you come to this where you draw this block diagram. So you want a wish list, you make a wish list and you make a block diagram for that wish list, and then you try to integrate parts and parts. Okay, probably the next 15 minutes. Okay, last 10 minutes I'll open for questions, but I'm sure you will not ask any questions, but so I'll make it the last 5 minutes, and then in the next 20 minutes we'll go through a couple of companies contests, and then see what were all presented in those contests, and what are the projects which made the cut, and then we will see how they came up with those ideas and things like that. Okay, so this is, I want everybody in the second year or in the third year, any year for that matter, to make a block diagram of a wish list of product which they want to make. Okay, and then split it into individual components. Like I want to make make a rocket, abdina kashtam, but make a ventilator, make a IoT controlled smart garage which can open and close door. I want to make a product which can do home automation. I want to make a product which can count how many students are there in the class, how many students are not attentive in the class. In a virtual classroom la kashtam, but in a physical class, how many people are not active, how many lights are on. I want to make a system which can, any product for that matter. And actually in the product material, if you make a nice product, the product will make it. Okay, take any product for that matter. Oyo nu oru hotel chain vandadu. It's not that there was no hotel chain before, yeah. They made something, it was good, and then it made it to the cut. Ola came. It's not that we were not using cab before that, but then Ola came and it has a huge market now. Okay, Big Basket came. It's not that we are not buying groceries before. Okay, but then Big Basket came, and Big Basket came after Amazon came. After Amazon came, after Flipkart came. But then still Big Basket found a market for it to order groceries to the home. Google came. Google Meet was there, and then Zoom came. Zoom is still making money. Uh, Flipkart came. Amazon was there, and then people from Amazon started a company called as Flipkart that even made money. Think of any product like this. You have your laptop. I have a Dell laptop, my office laptop. I have a HP, my personal laptop. Both these companies are making products. Both of them are making money. So if you look at it, there are very few products which are actually original, innovative. Okay, some people might come up with something like that. Okay, but then it's not necessary that if you are making a living, it's not necessary that a product which you want to make should be unique in the world. Okay, as long as there is something which is creative in that, there's some amount of creativity associated with it, it will still make the cut. Look at all the washing machine options available. You have 20-30 washing machine brands, right? If it were like only the individual which makes washing machines should stand out, there'll be only one washing machine brand, there'll be one TV brand. But it's not like that. The market is so big, anyone who makes something decent will actually make the cut. So what is required is uniqueness, which is absolutely required, but it is not that you have to make a product which is not there in the world. You can still make a product which is okay. Professor was telling you guys won a project, right? So if you look at that project, it will probably be not the first one in the world. Okay, you might have taken it from some place, you would have modified something to it, would have added some knowledge to it, some more intelligence to it, and the factor mattumda anga matter. So as long as you can add some amount of value added to it, you will still make the cut. So அதுதான் நான் ரெண்டே ரெசிபி தான். ஓகே, இதே தான் சொல்லுவேன். இன்னொரு 2-3 ரெசிபி இருக்கு. ஸோ ஃபர்ஸ்ட் ரெசிபி இஸ் யூ ஹாவ் அ லாங் டேர்ம் பிளான். ஒரு கான்டெஸ்ட்னு அவங்க அனௌன்ஸ் பண்ணி அந்த 20 நாளுக்குள்ள நீங்க கான்டெஸ்ட் ப்ரிப்பேர் பண்ணோம்னா ஒன்றும் தேட முடியாது. அந்த கான்டெஸ்ட்டுக்கு we have our own goal which we are running towards. This contest will come. We pick out from our repository what we can add together and make this contest, make a cut to this contest. அதை நம்ம பிக் பண்ணி ஒர்க் பண்றோம். That is the first idea. So the final goal of that idea is you add all these repositories, and on the repo vச்சு you make an absolute good decent final year project. Okay, it can be a paper, it can be a working demo of a product or anything, but you build for that right from this year. It can be very small. I have iterated it quite a few times. So you make a small addition, keep on adding something. Okay, இதுதான் உங்களோட ப்ராடக்ட் அப்படின்னா மைக்ரோ கண்ட்ரோலர் கிளாஸ் முடிஞ்ச உடனே டெம்பரேச்சர் சென்சர் எடுத்து I2C வழியா மைக்ரோ கண்ட்ரோலருக்கு இன்டெகிரேட் பண்ணிட்டேன்னா that is 1 quarter's job done. ஓகே, அதே அந்த I2C இன்டர்ஃபேஸை ரீயூசபிளா எழுதியிருந்தோம்னா அதே I2C இன்டர்ஃபேஸை வச்சு இந்த ஆக்சலரோமீட்டரையும் கண்ட்ரோல் பண்ணலாம். அதே I2C இன்டர்ஃபேஸை வச்சு இந்த பேட்டரி லெவல் மானிட்டரையும் கண்ட்ரோல் பண்ணலாம். ஸோ அந்த ஒரு இன்டர்ஃபேஸை உருப்படியா படிச்சோமா, if you study one interface very good, you will make it across all the interviews as well. Okay, so that is one idea of doing the contest. Yeah, you do the contest, you get money, you get all those stuffs, but then you have a thing to speak over in your interviews. So அதுக்கும் if you make incremental progress every year to understand a protocol, to understand how things work. இந்த ஒரு சென்சார் இருக்குன்னா அந்த சென்சாரை எடுத்து அனலாக் இன்டர்ஃபேஸ் பண்றது கொஞ்சம் அனலாக் படிப்போம் அப்படின்னா ஒரு தடவை மெஷர் பண்ணி பார்த்தீங்கன்னா வாழ்க்கையிலே மறக்காது. ஒரு டிஃபரன்ஷியல் ஆம்பிளிஃபயர்னா என்ன அப்படின்னா அதை ஒரு தடவை பண்ணி பார்த்தீங்கன்னா யூ வில் நெவர் ஃபர்கெட் இட். ஸோ ஆல் தீஸ் ஸ்டெப்ஸ் if you keep doing it physically, you get lot of confidence in doing that. That gives you both the confidence to make it to the project, also to face someone on your interviews and things like that. Okay, so that is 40 minutes down the lane. I will go to this. I wanted to show you this set of, this is a contest which this company runs. You know what? Can somebody type what processes? What processes do they do, Satish? Nice. It's a core company that works on chips. Do you know what processor they do? What processor they do you know? Okay, for mobiles mostly. Yeah, that's right. So most of the mobiles which you have will have a Qualcomm Snapdragon or something like that. Okay, so we are going to look at a contest which is being conducted by that company, and then we will see what all projects which made it to the cut. Okay. Okay, so okay, so we'll look at a couple of companies on what they do. I'll just pick 3 out of, I will just pick the winners out of each year and then look at what they did. Okay. Okay, we'll start. Okay, this guy takes so much time to load. Okay, these guys made an made a camera which can do all these kinds of detection. Okay, we will read what. Okay, this Scarlet, Uncanny Vision makes this video cameras which can actually do what is this post processing of the images to find out what is the serial number of your car, register number of your car, find out distance between them, whether the place is blocked or not, making camera post processing and things like that. So this is okay. This company, okay. One thing to look at. If you look at this contest, people from different walks of life made it to this contest. Okay, there is no one good project or bad project here. So if it is like an smart city hackathon, which let's say you are working towards, then at least you are. But even then also there is no good or bad project associated in it. Okay, so you cannot say a smart meter project is bad than a smart water okay, that still comes to a metering system. A smart a garbage monitoring system or a traffic reduction system is no good or bad when compared to an metering system which monitors the light and the usage of electricity and things like that. So there is nothing good or wrong with respect to a project. So okay, if that is the case, then how do you actually evaluate a product? Let's say you are there. Okay, you are given with idli and chicken biryani and discussion. Let's say I like both of them. Okay, it's not a direct comparison. Yeah, it's not like comparing chicken biryani from Talapakatti and Buhari. Okay, so in that you have an one-to-one comparison. You can say, okay, the chicken piece was 2 meter by 2 meter in that, it's 1 meter by 1 meter here, so this biryani was better than that, or something like that. Okay. But if you have to compare a Mysore pak and a chicken biryani, there is absolutely no common point to compare. You can probably compare the hygiene in it, but there is nothing else for you to compare them one on one. So if you are given with such a product, such two products, okay, how will you compare them? So that's okay. That is okay. Okay. I was one of the evaluators for this latest. There was a toy hackathon announced by the government of India, right? Was anybody aware of such a? Okay, I even saw something from your college as well. I think I'm not sure. Okay, I didn't mention the department or anything, but I think I saw an a product from RMK for a toy. RMK or RMD, I'm not sure. So I think I remember seeing one from that. So I was one of the evaluators for it. So if it is a toy, but then you get a toy which is based on literature, and then you get a toy which is based on electronics. Okay. So how do you evaluate both of them? Okay. Then there is no competition, right? There is absolutely no competition. So you cannot compare both of them. So what happens is you take your product and you compare it with your own standard. Okay. You see how good an implementation is. You see how he has evaluated his limits and how he has come up with a decent uh, um, approach towards solving the problem which he has taken. Okay. So நான் என்ன சொல்ல வரேன்னு புரியுதா? So that is doing an which was doing an camera. So there is no way you can compare these two products. Okay. So there is absolutely no way you can compare these two products as an as um, two same products. Okay. So you have to figure out a way to compare these two products. How do you do that? Is based on how you approach this product as such. Okay. So that is the way to ensure, that you have an common understanding of your product. So there is no competition outside, all the competition is from inside. Okay. If you think of that, then you are sure that there is no competition outside. So what you are working is towards your own competition inside, and how that happens is by comparing what you have been doing so far. How do you improve what you have been doing so far? By keep on working on it for a long time. Okay. Um, so that makes us look at all these products. So I will share you the link of this, so you can go and look at what all the projects which made it to the cut for one of the most famous designing challenges of the world, and then you can figure out uh, how you can design a product, what all things you should consider while doing it. Okay. Let's look at one more project which was Light Metric. So they do fleet management basically. So this was one of the companies which made it to the cut on this Qualcomm demo. Okay. I'll go to something on 2020, which is very close to what we are doing now. Okay. This is a diagnostics. This is an okay. Let's look at this. This is actually a wellness system. Okay. So they made wearables for monitoring vitals, which is very close to what you will do on a COVID or anything like that. Um, so these kind of products is what makes it to a cut on one of the world's best designing contests in the world. Okay. Then you okay. Okay, so that is pretty much what I had for the discussion as well. Okay, so I wanted to show you the recipes for making. I wanted to show you a couple of contests and tell you this is what you should be doing, and pretty much that. Okay, so that's the last 10 minutes. So I will stop and let you ask questions if you have anything. Do you have any questions, anybody? If you have a product, yeah.
Yes, sir. Sir, while planning for a project or something like that, people always adhere to a approach like double diamond approach, and there are the business support approach and things are like that. So, is it
Yeah.
quite necessary to stick to one, or I, actually I haven't made one, but is it quite necessary to stick to one?
இல்ல Shobhan. Okay, so all these, okay, I did a session on double diamond with this, probably with the same set of people, probably 4 or 5 months ago. But I have also read about that, but I have hardly seen any innovation happening out of an restricted system. Okay, when you restrict your inputs, then then uh, um, then none of the innovations can happen. Okay, so all these will try to guide you to some extent, but innovations happen always tangential to any approach. Okay, so if you try to restrict yourself to what to an approach, like in the next 2 days you find out something which is good, in the next 3 days you find out a way to do it, that that is slightly not possible. Okay, but we have to also take into account, okay, why this, we have to actually look at why these approaches came. Okay, so initially inventions were happening at a different place, and marketing was happening, and public production was happening at a different place. Okay, then at some point invention and uh, money start has to happen at the same place. Okay, let's say at some point all the papers were being done by colleges, and then companies took those and then started making money out of it. Okay, so all the innovations happened in colleges like Stanford and things like that, and then companies took that and then started making products out of it. But then now they are decoupled. Okay, so in companies get colleges get grants, and they work on their own timeline. They make a product whenever it is available. These companies started marketing that. Okay, then at some point the companies started making innovation as well as products. Okay, then they started putting a timeline to it. So they wanted to do the next innovation in the next 3 months. Okay, so if you want to do this, if you are time bound, then you have to make a process to do it. So which is like get up at 6 o'clock in the morning, innovate for next 2 hours, then have breakfast, innovate for the next 2 hours, and things like that. But usually when innovations doesn't happen that way. If it is methodical, then you can do it to some extent, but then innovations don't happen that way. So uh, so you so then what happened was companies started funding projects. They will fund it to some extent, and then let's say 3 years we'll fund it. If you don't make anything, we'll kill the project. Okay, so that was the approach after that point. Okay, so you give someone 3 years time, and then they can explore, do whatever they want, and come up with a solution within 3 years. If they don't come out within 3 years, then that project is no longer funded. Okay, so if you take that approach, then you put a lot of pressure on the person who is working on it. Okay, that's typically that's what is happening in PhDs now. So you give that person a 5-year time or a 4-year time or a 6-year time, and then you ask them to do something out of it. And that's reasonable, right? So you give a 6-year time to them, and then you expect something good to come out of them in the 6 years of funding. So that is so time bound innovations are always limited in terms of capacity. So if you bound it in time, you don't get a wow innovation. You get an okayish innovation, but then you still have to keep doing okayish innovations and hope that at some point you hit a wow. So that's the purpose of this approach. So you can follow an approach. There is nothing right or wrong in that, but you always your experiment should lead to a conclusion. So as long as you have meaningful experiments which you are doing, you don't randomly try this stuff, get bored, do something else, come back, do something else kind of thing. You have a methodical approach to hit a problem hard, then you will find a solution for it. So that's I think instead of these approaches, I think you should be looking at it this way.
Yes, sir. Thank you. Thank you so much, sir.
Yeah.
To promote e-vehicles, sir, to reduce air pollution, sir. So can you suggest any novel ideas or projects towards e-vehicle industries for our students?
Wow, super, sir. Thanks, sir. Thanks for the question. So, okay, yeah, e-vehicle seems to be an interesting happening market, right? So you can pretty much do a lot of stuffs on it. So um, the very basic thing is the batteries, on how to dispose the batteries and how to charge them, how to recycle them effectively and things like that. So, but that is mostly chemistry and chemistry related stuff. So that has to do with materials, which is kind of very different from what we are trying to do as part of engineering. Okay, so then you take high voltage drives. So that means handling higher voltage, higher current, uh, driving without ripples, and ensuring that the motor gets a decent voltage, the rate of ramp up and ramp down are very smooth. So that is one set of things which we can do with electric vehicles. uh, so mostly voltage handling, um, and relay and driving high volt transistors fed and uh, with the ability to drive the wheels and things like that. One problem which I see with recommending an EV project to college guys is the amount of infrastructure which you might have to take. Like, if you want to really prove your drive capability, you need a bigger car with all the infrastructures and things like that to ensure that happens. So that if you can solve a couple of infrastructure problems, then taking up anything on that will be a really interesting. You have to also take into account all the safety considerations, considering if you cannot brake the car, what if it goes and hits something, and things like that. So making a product as such is very much high ended for an. It's like tennis for common people, golf for common people. So it's an high end and heavy, financially consuming a lot kind of a project. But as long as we can split it into smaller parts and then do a meaningful prototype out of it and collaborate with EV manufacturers, then we can still do it. Uh, we can take up any stuff for that matter. There are a lot of open challenges there. So we can take up anything from that, from people who are working on it, like onsemi. TI is working a lot on it. Qualcomm is working for making this AI part of the EV. Microchip has a lot of high voltage drives which can be used for EVs and things like that. So we can take any valid problem from it and fix it. So provided we have enough safety and infrastructure to do this. I hope that answered the question.
Thank you, sir. Thank you.
Students, any questions? Thank you, sir, for your presentation, sir.
Thank you.
Now I request our dear E&I student member in IIC and IEI to propose the vote of thanks. Sangavi.
Yes, ma'am. Thank you, ma'am. Good morning to one and all present here. It gives me an immense pleasure to deliver the vote of thanks for this event to all dignitaries assembled here. I take this golden opportunity to thank our respected chief guest, Mr. Ganesh Skanda, Senior Engineer to Microchip Technology, who honored this function with his inspirational faculty members and the students for their active participation. With these warm words, we move to the end of this webinar. Thank you.